Okay, we're going to do the fundamental theorem of calculus 2. Before we get there, we're going to talk about the average value of a function, which also means the average height of the function. So this also means the height. Okay, so if f is integratable, then here is your average value formula. Okay, you're going to integrate the function from a to b, but you're going to divide by whatever that difference of the range is. Okay? That is the average value, or it's the average height of a function. Okay, so this kind of just walks you through why it works, is because if you integrate, that gives you area. Alright? If you do, this bottom right here is just the width of a rectangle. So area over width, well, area is the width times height. So this is just going to give you the average. The w's cancel out, and you're left with height. Gives you the average height. Now, when we start talking about, like, velocity problems, then it's not going to be average height, it'll be average velocity. Okay? So, whatever you're integrating, if you're integrating position, you're finding average position. If you're integrating acceleration, you're finding average acceleration. Okay? Okay, so the average, let's just do one problem here, and we'll move on. We'll talk about what it means as well. So the average value of this function right here on the intervals, we need to find it real quick. I'm going to do a real quick sketch of what this thing looks like. So here's a graph from 1, 2, 3, 4. So this function looks something like this. Okay, kind of shoots up pretty quickly there. It's not to scale whatsoever. So what do you think the average value of this function is? Just by looking at it. So if I think this bottom right here is 1, the top value I believe is 40. Give me a number that you might think might work out. Estimate. Estimate this answer. Pretend it's multiple choice on your assessment. You're clueless. Okay, I like it. Someone just said 32. How did you get 32? Very good. But you at least guessed within a decent range. Why am I saying that's a decent range to guess at? It's between 1 and 40. I agree. Good job. Could be 32. You've grown so much over the past year. Okay, so to set this up, what's my setup to find the average value of this? It's 1 over 4 minus 1, which will be 3. Integrate this from 1 to 4 of 3x squared minus 2x dx. So what's my front number? Someone just said it. Comes at 1/3. Okay, let's go ahead and integrate this. What's the integral or antiderivative of 3x squared? X cubed. Minus. We gave you easy ones on purpose. X squared. I'll just put these in little brackets. Since I put it in brackets, I can just do this. Maybe a little different notation what you're used to, but same thing. Okay, now I'm going to plug in a 4. So when I plug in a 4, I'm going to get 64 minus 16 minus 1 minus 1. And we multiply that answer by okay, so what's 64 minus 16? 48. I mean, 1 minus 1 is. So I have 1/3 times 48. How close is Mason? I don't know. He doubled. This is exactly half of his answer.
It's just how he thinks This is how it works.
Okay, so on multiple choice, when you're like, I think it's this answer, take half of that, and that's the correct answer. If it's not an answer choice, just make like a choice E or F or whatever it is, and then circle it. Only for you. And if other people do that as well with your correct answer, then fine, I'll give it to them too. Like for some reason, Neelish also puts the exact same question, that exact same number, and circles it, I'll give it to him. Nobody tell Neelish I'm joking. I want to see if he does it. Okay, so again, if I'm trying to find the average velocity, this is my formula. Okay? I'm going to integrate velocity and divide that by the difference of, if it's velocity of time, it's difference of time. It's going to find my average velocity. So S of t represents position. So this is going to give me my average. It's not a trick question. I'm integrating my position, dividing that by the time difference, I'm getting average position. What if I do this to acceleration? I get the average acceleration. I agree with you. If I integrate acceleration, I get velocity. But if I'm dividing by a time again, what's velocity divided by time? Acceleration. So that's how it works. Okay. So units. The unit for the average value will be the same unit of the function that you have started with. So here's the explanation. I'm not filling in these blanks. Just whenever you have to interpret the meaning of an average value problem, your answer will be the average whatever we're using. So this example down here, it will be a velocity of, in this case, a rocket in feet per second from, and it'll give us the time, and then we'll kind of go from there. Okay? So this is just a generic explanation that you can use. It's not the only explanation you can use, but Jonah, please do this word for word. Just you. Everybody else can figure it out. I don't want more than one sentence, Jonah, or a run-on sentence. I don't want a paragraph. Did you see your grade last time? You were equal to Neelish. We're not talking about your grades on this on this recording. No, I was saying your last assessment. Okay, yeah, okay. All right, so here's the part of A for your response. Okay, rocket A has positive velocity. After being launched upward at ground level, the velocity of the rocket is recorded for selected values of t over this interval, as shown in the table above. Using the correct units, let's explain the meaning. I'm only explaining the meaning here of this right here. So what is this 1 over 80 from 0 to 80 v of t dt? What does that mean? It's the average velocity. Of what? Of the rocket. What's my units? Feet per second. In feet per second. Now, usually for these problems, you'll have an answer to go along with it. We're just not finding out what it is. So, like, usually they'll ask you to find the average velocity, and then they'll say explain your meaning. So you would just say average velocity of the rocket is 20 feet per second. You'd say that. From what are you have to state the endpoints. So what are my time intervals? From 0 to 80 seconds. You need the time. Like, what if Neelish tells me, hey, coach, I ran. My average velocity was 20 miles an hour. First thing, I'm going to say to Neelish, well, if your average velocity was 20 miles per hour, we probably recorded you for a split second. That's probably it. We're not recording you over like a mile. You're not running 20 miles over a mile, right? So the endpoints really matter, okay? Neelish, you can get up to 20 miles per hour. You can. For like a second. I'm joking. You'll never get up to 20 miles per hour. Never is going to happen. That would actually be pretty good. I don't know. Am I faster than Neelish? Wow. Alright, I know what we're doing after the AP exam. We're going to go out to the track, and Neelish and I are going to race. You're going to find our average velocity to at least make it calculus-based. Neelish, it's on. It's on. I'm putting it on my calendar right now. I'm going to race you. All right. Okay. Number 3. So it looks like we're just going to go through an entire free response here, which is good. So as a pot of tea cools, I don't know why the table's in the middle of everything. We'll just deal with it. So as a pot of tea cools, temperature of the tea is modeled by a differentiable function h for 0 to 10, where time t is measured in minutes and temperature is measured in degrees Celsius. Values of h and t at selected values of time are shown in the table above. Use the data in the table to approximate the rate at which the temperature of the tea is changing at 3.5. Show the computations. Let your answer indicate your units of measure. All right. How the heck do I find the rate of change here given a table? It says approximate, so that's really nice. How do I approximate the rate of change? You do what? Find the secant from 2 to 5. So I'm looking at these guys right here. This is going to be my average rate of change between those two. Okay? Which is going to give me approximately my rate of change of 3.5. Alright, so we're going to do h of 5 minus h of 2 all over 5 minus 2. That gives you 1 point, by the way. That's 1 point. Did I actually do any math yet? No, I just set it up. That's a point. Equals, well, what does it equal? 52 minus 60 all over 5 minus 2. What does that give me? Negative 8 over 3. That gives me my second point. I'm still missing a point here. Okay, what are my units? Degrees Celsius per minute. Why is it per minute? Because we divided by time. And we did this. We're finding a rate. It should be per something. Oh, yeah. Part B. I'm excited. Use a trapezoidal sum of 4 subintervals. This is great review for our test coming up. This really is wonderful. Indicated by the table to estimate 1 over 1/10 of 0 to 10 h to t dt. Show your computations that led to your answer. Let's do it up. Let's go ahead and do a trapezoidal sum. This is so fun. I'm enjoying myself so much. I hope you are too. Okay. So first off, I'm going to multiply my answer by 1/10. Here we go. here is my, I'll do it in blue. Here's my first trapezoid right here. How did I find the area of a trapezoid? Remind me of that, please. The average of the bases times height. So that's why it's B1 plus B2 over 2 times height. Okay? So what's the average here? I'm just going to do the work. So it's going to be 66 plus 60 all over 2 times my height is 2. In this case, my height is going to be time. Okay? Plus, let's go to the next interval. This one will be all different.